Today we solve Edexcel International A-Level Mathematics, further Pure Mathematics F1. So question number 1, at first read the question carefully. Use the standard results for sum of R square and sum of R cube to show that for all positive integers n. So we have to show that. So we at first have to consider left hand side. We have to prove it. So sum of right here, sum of R square R plus 2. Simplify it or equal to 1. So we can multiply R square into R. So we can multiply R cube and 2R square. So split the sum R cube and 2 into sum of R square R equal n and R equal 1 to n R equal n. First natural number, we know that sum of R cube equal 1 by 4 n square into n plus 1 whole square plus 2 into, and we also know sum of R square equal 1 by 6 n into n plus 1 and 2n plus 1. So this is two terms. So now we can common n into n plus 1 because here also n into n plus 1. So n into n plus 1 common. So remaining part is n into n plus 1 remaining, and denominator is 4. Second terms, if you simplify it, this is denominator is 3 and 10 into n plus 1 is common. So remaining part is 2n plus 1 divided by 3. Now we can take LCM. 4 and 3, LCM is 12. So n into n plus 1. Take the LCM is 4 to 12. So 12 divisible by 4, we get 3. So we can write 3 n into n plus 1. And this is 4 into 2n plus 1. So simplify it into n plus 1. Denominator is 12. So 3n into n, 3n squared, 3n into 1, 3n plus 4 into 2, 8n plus 4. So now we can write it. So 1 by 12 into n plus 1, and numerator part is 3n squared, and 3 plus 8, 11n plus 4. Now right side is true, that a equal 3 and b equal 11 and c equal 4. Sure. Question number 2. At first, read the question carefully. In this question, you must show all stages of your working. Solution relying on calculator technology are not acceptable. Given that x equal 2 plus 3i is the root of the equation, this one, and first a number. So write down another complex root of this equation. So we know conjugal complex roots are conjugal. So this answer will be x equal 2 minus 3i. So question number B, use algebra to determine the other two roots of the equations. Already we have two roots, so make a factors of two roots and multiply it, then we get the quadratic. So first root, we can write x equal minus 2 minus 3i and multiply x equal minus 2 plus 3i. So multiplication x squared minus 2x and 3xi. Now multiply by 2, negative 2 minus 2x and minus 2 plus 4 and minus 6i. Now multiply by minus 3, 3xi minus plus 6i and minus 3, so we can write minus 9i squared, and now we can write x squared. This part is eliminate, and 6i eliminate. I cancel out actually. Minus 2x and minus 2x minus 4x and plus 4, and we know I square equal minus 1, so plus 4 plus 9. Finally, we can write x square minus 4x plus 13. So, process is long division. Actually, if you divide by x square minus 4x, so x square minus 4x plus 13. So, long division it will be. So, our function is 2x to the power 4 minus 8x cubed plus 29x squared 12x plus 39. So we have 22x to the power 4 and we have x squared. So if we multiply 2x squared, then we get 2x to the power 4, 4 to 0, 8x cubed, and 3 to 0. 13, actually this one is 13, 13 multiplied 2 plus 26, and this one is 29, 26 x squared. So then subtraction, sign will be changed, cancel out, and 29 minus 26, 29 minus 26, so it will be 3x squared minus 12x plus 39. So first term is 3x squared. We have x squared, so multiply by 3. Then we got 3x squared minus 12x plus 39. So remainder is 0. So already we get 2x squared plus 3. 2x squared plus 3. If you write another, we have to find another two roots. So 2x squared plus 3 is the another factor of this polynomial equation. So we can write this factor equal 0, and 2x squared equal minus 3, x squared equal negative 3 divided by 2, and x equal plus minus root 3 divided by minus root 3 by 2. We can write plus minus root 3 by 2i. So already we get these other two roots. And question number C, show all 4 roots in a single orthogonal diagram. So you know the x-axis and y-axis. So x-axis is real part, and y-axis is imaginary part actually. So first root is 2 plus 3i. So this is 1 and 2. Real part is 2 and 3i. 1, 2, and 3. So this first one is this. And second root already we get x equal 2 minus 3i. So 2, 1, 2, 3, negative 3. So second one is this gone. And finally, from question number B, we got plus minus root 3 by 2i. Root 3 by 2i. So it will be, there is no imaginary part, so it process the y-axis. So like this 3 by 2 root 3 by 2, this the equation is here actually. So finally it's the answer. At first, read the question carefully. Question number 3, the rectangular hyperbola Hayes has Cartesian equation xy equal 9. The point P with coordinates 3t, comma 3 by t, where t is not 0 lies on a's. Use calculus to determine an equation for the normal to a's at the point P. Give your answer in the form ty minus tq x ft. So by using calculus, at first we have to find the gradient. So we have an equation dx x y equal 9. So make a subject of y equal 9 by x. So now we can write y equal 9 x minus 1 dy by dx equal 9 minus 1 x power minus 1 minus 1. So we can write 9 by x square. So substitute x equal 3t. We got m. So minus 9 3t square. We got minus 1 by t square. So equation of normal is y minus y1 equal minus 1 by m x minus x1. So y1 is 3 by t minus 1 by t square x minus 3t. Simplify it. Take a LCM, so we can write yt minus 3 equal 1 by minus cancel out, so t square x minus 3 t yt minus 3 t side change, so t cube x minus 3t square. So yt minus 3 equal t cube x minus 3t4 4. We have to like this forms ty minus tx cube. So we can write ty minus t cube x equal minus 3 t power 4 plus 3. So we can write ty minus t cube x equal ft. That is the final answer. Question number B. Given that t equal to, determine the coordinates of the point where the normal meets a's. Again, give your answer in the simplest form. So substitute t equal to in equation of normal. So we got equation of normal is ty minus t cube x equal minus 3t power 4 plus 3. So t equal to, so 2y 2 cube x equal minus 3 t power 2 power 4 plus 3. So we can write 2y minus 8x equal minus 45. So x equal, we have another equation, x equal 9 by y. So 2y minus 8 into 9 by y minus 45. Take LCM to y square 72 equal 45 minus 45, and more simplify to y square minus 72 equal minus 45y. Make a quadratic equation to y square plus 45y minus 72 equal 0. Using formula as 45 plus minus root over 45 square minus 4 into 2 into minus 70 2 into 2. By using calculator, we get 3 by 2 and minus 24 finally. So point of P equal, so we have to find x equal 9 by y. So x equal 9 divided by 3 by 2 equals 6. And another point is x equal 9 by minus 24, that is minus 3 by 8. So our point, we have already point P. If you substitute t equal to, we got 3 into 2 and 3 by 2. So we got the value 6 and 3 by 2. 3 by 2. So 6, the value of x is 6, is the point of P. So another point of the normal equation is x equal minus 3 by 2. So x equal minus 3 by 8, comma 24. So another point, the final answer is minus 3 by 8, comma minus 24 is the another point, final answer. At first, read the question carefully. Question number 4. Here A is a 2 by 2 matrix where K is a constant. The transformation represented by A transforms triangle to triangle T prime. The area of triangle T prime is 3 times the area of triangle T. So determine the possible values of K. So at first we have to find the determinant of A. Determinant A equal minus 3 into K, so minus 3K, and minus plus 24 modulus. So determinant A equal, so minus 3K plus 24 equal 3 times, so it is 3. So at first time we have to consider positive, so minus 3K plus 24 equal 3, then minus 3K equal 3 minus 24, minus 3K equal minus 21 equal 7. When we consider negative, so 3K minus 3K plus 24 equal minus 3. So minus 3K equal minus 3 minus 24 minus 27 and minus 3K divided by 3, so K equal 9. Question 2. So we have B 2 by 2 matrix and BC also given. Now where is a constant determined in terms of A, the matrix C. So BC given, so we can write BC equal 2, 1, 5, 4, 1, 2. Multiply both sides by B inverse. B C equal B inverse 2, 1, 5, 4, 1, 2. B inverse B cancel out, that is C equal B inverse 2, 1, 5, 4, 1, 2. So now at first you have to find B inverse. So we know B inverse, determinant of B is 3A. B inverse equal 3A 1 by 3A minus plus 8, and diagonally change and of diagonal sign change, so it will be 4 and minus 2. Substitute here 1 by 3a plus 8, 3 minus 2, 4a, 2, 1, 5, 4, 1, 2. So multiply it 1 by 3a. First row, first column. First to first column, 6 plus 4 minus 4 plus a, 15 plus 16 minus 10 plus 4a, 3 plus 8, first to first row. So minus 2 plus 2a. More simplified, we can write 1 by 3a plus 8, 10 minus 10, 4 minus a, 31, 4a minus 10, 11, 2a minus 2 is the final answer in terms of a.